Good morning. Thank you for all coming out. This talk is your configs are bad and you should feel bad. My name is Stephen Hall. I work as a consultant at Security Compass doing kind of whatever they tell me to. My main background is in network security. I do web, mobile, config reviews, architecture design, jack of all trades, definitely not a master of any of them. Yes, I wear the Santa hat throughout the year. It's so that people on the subway leave me alone and don't ask me any questions. It works pretty well. What this talk is about and why I chose to do it. So I've been to a couple of cons. I've spoken at some before. And a lot of the talks revolve around Windows. Why Windows is broken, how you can easily beat it. PowerShell is the new hotness. Everybody's talking about it. But everybody has at least one Linux box on their system that they just kind of like tuck under the desk and ignore. And those boxes are just as easy to break, pivot, as a Windows box would be. So I kind of decided, well, since not a lot of people are talking about it, I'll try and give it a shot. So what this talk will kind of cover is what are some of like the really common configuration issues that people have. Most people know them. Some of the more forgotten or uncommon issues, and hopefully how you can go about to fix them. How many people in the audience are on like an offensive team? Wow. On a defensive team? Okay, this works. So we're going to go over the things we know about. Slides like this have become really easy to manage over the last couple of years. I can just put logos up there now instead of like walls of text of like why these things are bad. So because this box is typically like under a desk, nobody knows who even manages it. So they tend to fall behind on patches, which is good for me. Because you don't patch, I get to elevate privileges if I have access to it. Thanks to like glibc ghost and heartbleed, I can extract information or gain a shell on it remotely. How many people here when like heartbleed and glibc ghost came out actually patched? How many of you actually thought you patched properly and end up actually didn't? So what happens is, for things like glibc and heartbleed, yes, you installed your new patch, but all of the services that use the vulnerable binaries were still running, were never restarted, and were still vulnerable to it. Does that ring a bell to anybody? And then you also have services such as like IBM, and like anything that statically compiles their own versions of these libraries along with you. So you've installed this application, you've patched your main operating system for it, but you're still vulnerable because IBM hasn't released a patch. And if you're lucky and you still have a service contract, you will hopefully get a patch for it when they feel like releasing it. Until then, you kind of just have it there on your network. Does that sound familiar? So main takeaways from this one is just kind of, just because you've installed your update doesn't mean that you've applied it properly. And I've seen places, going to places and it's like, yeah, we patched, we're good. Did you restart the service? No. Well, this is why I'm still seeing all of your information from Heartbleed. And this may or may not have happened like 2 months ago. So the same thing kind of applies to services. Typically what I see is a developer needs to test something. And they're like, oh, I have access to this box. I'm just going to install JBoss. I need to spin up an application really quick. I'm just going to go hit yes, 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 so that I can get this out of the way and continue along with my job. Does that also ring a bell to anybody? These are the boxes that have your default configurations, admin password, listening on all of the interfaces. So I come along on your network, I'm like, oh, what does this box do? Yay, I now have an access to a shell. Typically, I see these in dev environments because they just kind of want to get things done and out of the way. A common other thing I see for services is because they were trying to test something to get it working, they don't actually know what features they needed. So during the installation process, they're like, yeah, just install everything. I'll figure this out later. And then they never stop and go back and be like, well, I actually don't need like this interactive SQL editor. Or don't worry, guys, it's a feature. It's a feature. We'll fix it in prod, and then they never do. So kind of be aware of what your systems are doing and what people are installing on them. Just because they say it's for a test doesn't necessarily mean that they're right. So some of the things you can do about this. How many of you know when your servers were last patched? How many of you know who's in charge of patching those servers? Yeah. Everybody has at least that one box. It's like, oh, yeah, Brad used to manage this box. Where's Brad? No, he left 2 years ago. Back to the services. Just because this box was stood up as like a MySQL server, why is it running JBoss? Why is it running Mongo? Why is it running all of these other things that it's not supposed to? Are they really needed? Probably not. It goes back to, well, it's default. I just needed it to work for this test. I'll clean it up later. This umbrella kind of, they go hand in hand, passwords and permissions. So when I get on a box, on a Linux box, what I like to do is I like to check everybody's home directory. Because Linux by default will create new files and folders with the permissions of 755, meaning everybody has read access to this folder or file. And because of that, I know a lot of people, myself included, store a lot of things in their home folder, backups of things I'm testing that, in case I do fudge them, that I can revert. All of like my custom scripts are in my home folder. And if you don't change these permissions, anybody can come along and just start to read all of these things. People may be wondering why fstab is under passwords. I have seen instances where a Linux admin needed to mount a Samba share on boot. I see some people smiling. They know what's coming next. On the Windows side, the share was configured properly to not allow anonymous access. So they put their DA passwords in the fstab file so that it could mount on boot. I wish I could make these up. These are real-world situations. So just because you can do it doesn't mean you should. There are cleaner ways to do it. None of them are actually much better, but they're at least not world readable. How many people know how many setuid files get installed by whatever third-party application you've installed on your server? Do you know what those files do? I don't. But I start to look at them, I'm like, well, this is not a part of your common Linux setuid files list. Maybe I'll take a deeper look at it. Maybe not during this assessment. Maybe I'll pull it down and start to look at it offline to see how it's doing things and if I can start to leverage that on, say, a later assessment or somewhere else down the line. Not all hope is lost. Like I say, these are the basic parts of system hardening, things that people often forget along the way and are fairly easy to fix. So what you can do, create a baseline of your systems. This kind of ties back into Hayden and Cheryl's talk. Like, if you don't know what your system is doing, you can't really identify when something's gone wrong or somebody else is on it. That being said, change your default UMask. The default is 022, which is the inverse of the permissions it gives, which never really made sense why they did it that way. But you may want to consider changing it to 077 so that when a user creates a file, that only they have access to it. But that's only part of it. This actually doesn't affect all the other files that they've created before. So you may also want to retroactively go back and be like, yes, I'm going to set each user's home directory to 700 and let them worry about the files underneath it. Or if you have root and you have the power, you could just do it yourself along all their files and then have them worry about why doesn't my script execute anymore. Don't store backups in world-readable places. I like this one because people store backups in temp or their home directories because I was just fixing something. I'm just going to put it here in the meanwhile, and some script will clean it up later. It'll be fine. And you don't necessarily need to do anything about the setuid files. Just be aware of them. I would say, if possible, delete them, but a lot of those applications start to go like really sideways when you delete files that they may or may not need. This problem has been solved before. There are a bunch of scripts and blog posts that go over the basics of it. They show you the commands that you can use to help identify these files, these directories. And I use them a lot. It helps. It does help me just automate through a bunch of my things. So you're probably wondering why I started with just the basics. And it leads into a story. I was performing a test. From an external point of view, we were given 20 hosts. That was it. By the end of the assessment, we'd compromised their entire DMZ, their entire internal network, and had access to all of their cloud infrastructure because of basic Linux configuration issues. It all started with a NoSQLite database, configured defaultly, listening on all ports, world readable to the internet. Anybody cares to take a guess as to what could potentially be in this NoSQL server? Passwords, yes, some proprietary information, but it was their chef configs. So if you don't know what chef is a configuration management tool that lets you configure and deploy servers on the fly to match your specific template. We pulled down that entire database, started grepping through for passwords, API keys, SSH keys, and we managed to find a bunch of passwords to various administrative consoles and a GitHub repo. So we pulled the GitHub repo. And in there, we found more passwords, more API keys, and we found SSH keys. So we tried these SSH keys along all of these boxes that we initially were scoped to. And voila, we found a Bastion host that was triple nicked to the internet, their internal network, and their DMZ. And the user that we had access as was SVN, which if you do a lot of Linux, if you do a lot of repository stuff, this account doesn't need to have a shell to do what it needs to do. If they'd simply set the shell to false, it would have been able to pull the repositories, no problem, but I wouldn't have been able to get a shell on their box. because of their home directory weaknesses, their default weaknesses, we were able to find Wireshark dumps of them troubleshooting something that had more credentials. They were nice enough to run Nmap a week earlier of their own network. So we didn't have to worry about that either. And one of the other admins was nice enough to store a backup in their home folder of their OpenLDAP server. So what did we do? We thanked them, started pivoting, cracking the hashes in their LDIF file, SUing to other users who had no password for sudo. And then we started to scrape all of that other information from the box and use it to pivot to everywhere in their network. Not a single exploit was run. I didn't need to fire up Meterpreter or Metasploit. This is all from external to everything, from no privs. The keys to the kingdom. Everybody is worried about the APTs, when all of this stuff is still rampant. If you're worried about China, you should worry about the kid down the block who's just running Nmap and being like, oh, what's this do? Also in the Git repository, we found like their entire AWS key store for prod and dev. So from that, if we wanted, we could have just taken their entire existence and blown it away and like had them scramble to figure all of this out while we deleted their chef scripts. What else we did do, because that NoSQLite database was admin by default, we added our SSH keys to all of their recipes and added a line that said, anytime you have a new instance, ping me, let me know, and I'll come and connect to it. And they were doing, at the time, this was a couple of years ago, so they were doing really nice things with like load balancing and Chef before AWS supported Chef natively. So they're doing all of this nice stuff. So a nice potential way in today's landscape is if you had that kind of access, if they're using ELB, their enterprise load balancing, I think, if you start like a DDoS attack against them, force them to spin up a bunch of servers, you now have servers that you can then use as a part of your botnet because you have access to it. It's the self-sufficient DDoS attack. The things we kind of forget about. I really only have 4 things on this list, and that's going to take up most of the rest of this talk. Oops. Everybody loves sudo. Anybody can think of anything wrong with these 4 sudo commands? Other than the people like right here. Anybody? Guy in the red shirt? Yep.
Vim can basically act as a shell.
Yep, Vim can act as a shell. Find has an exec flag. The other 2? Yep. And wildcards on copy are wonderful because they only check. It's like, yes, this first part matches, and it doesn't really matter what you put after it. So you get things like this. Like I say, Vim unless you can bash out. Find has a wonderful exec command where you tell it, if I find a certain file, run bash. So you tell it to find a file that you know exists. And copy, because of the wildcards, you can copy pretty much any file on the system to a location that you can potentially read, say with the less command that you now have sudo to. But there is some kind of hope for this. Sudo supports a noexec flag in the sudo config, in the sudoers file. And what that tells it to do is pretty much when a process launches when a process is launched with sudo with this flag, if it tries to create a child process, don't let it. Sounds wonderful, right? It has its drawbacks. The noexec flag only works on natively compiled, dynamically linked files. If your file is statically linked, it will ignore it. So all of your wonderful libraries, if it's also compiled on a different system, it will not honor this flag also. So kind of be wary of where you use it, or at least make sure that what you're supplying it to will actually honor it. Yeah, know what you're giving sudo permissions to. While vim and less may seem like benign commands at first, if you give them specific actions to particular files, there are still breakouts for it. Try to avoid wildcards where possible. If they only need to read, say, if they only need to copy access logs for that from that directory to move it to a certain directory, make sure that you give it that particular, give it that particular full file path. So the picture underneath, if you can kind of see it, shows that when the noexec flag is set, that when you try to run the same breakouts that you would for, like, say, find or VI, it returns an error saying you're not able to spawn that shell, and you're kind of stopped there. The copy command is also useful in other places, and I'll kind of show that in, I think, the next bunch of slides where I get kind of lazy and couldn't bother resetting my terminal. The wonderful world of Kerberos. How many people actually have Linux boxes in their environment that use Kerberos? Wow, that's a lot less than I thought it would have been. Maybe this won't be as interesting then. So Kerberos on older systems has a bit of weird nuances where they store your tickets in temp. Yes, they're only readable by you and root, but they still do store them in temp. There are 3 ways that tickets get generated for this process. One is when you run kinit to request a ticket for yourself. One is when you authenticate to a server using Kerberos. And the other is when you authenticate sudo using Kerberos. The first 2 have a weird behavior where these files actually do stay on the system after you are... You're not my supervisor.
More?
No, I still need to finish my presentation.
Thanks, Stephen.
Thank you. Yeah, so the first and third instances where you run kinit or you authenticate through sudo, those files actually don't get cleaned up when you when you close your session, either through SSH or if you are crazy people and run Linux on your desktops, they don't actually clear out. So if you log out of that server, those Kerberos ticket files are still there active until they reach their expiry time. And if you've gained root through some means that may or may not require an exploit, you can copy those files to your user and then leverage them to pivot to other servers. There is kind of weird behaviors for that as well. Though they do store in temp by default, you can change where they're stored. There is a semi-fix to this. You can use the keyring. A lot of the newer Linux operating systems, by default, will store your Kerberos tickets in your keyring and not in temp. And your keyring actually does get cleared when you close your session, so you don't have to worry about when you run kinit or if you do sudo that those Kerberos tickets are left as artifacts on your system. You can enable this by adding that wonderful default CC cache line to your KRB5 conf file. I learned the hard way that if you also forget to enable the keyring for SSH sessions, you lock everybody out of the box. My IT team was not too happy when I tried that and forgot to do that. Yeah, so that's the valuable lesson there. When you enable Kerberos, if it's on an older system that used to store it in temp, you also need to enable your keyring auto starts for SSH sessions so that when they try to run sudo, they don't get permission denied because they can't store that ticket in the keyring. So this is kind of how it works for me. If you look in temp, you can see that there are two files, one for KRB5cc underscore 1000, one for KRB5cc underscore 1001. The way these files are named are that they are that prefix with your user ID. So those last 4 digits are either your local user ID or your Kerberos user ID, depending on how you're authenticating initially. As you can see, or actually maybe not see. So the first file I have, I'm a user called Paul. I have 2 Kerberos tickets in temp, and I use that same sudo copy command that allowed the wildcards to pretty much copy that other user's key into my key space, overriding my Paul key. But when I run klist again, I now have an admin Kerberos ticket that I can then use to SSH as admin to other boxes or authenticate to web services that use Kerberos authentication on a Linux server. How many people actually knew about the Kerberos temp thing? No? Other than you, Jeff. So, SSH agent forwarding. I love it. It serves a purpose. It's really useful. But it also has certain inherent weaknesses in how it kind of allows you to authenticate. Because of that, you would typically use it if you're in kind of like a jump box environment where you SSH to a central server and that central server then has access to other servers behind it that you don't have direct access to. And you don't necessarily want to put your SSH keys on this central jump box that everybody has access to. So you use SSH agent forwarding so that it will proxy your authentication requests back to you and allow you access. An attacker can hijack that SSH socket, that authentication socket, and masquerade as you on a system. Unfortunately, there's no real fix for this. I'm sorry. The only real solace I can provide you is if you're using servers that don't require, that aren't used as jump boxes, and you don't need to hit to gain access to anything else, is in your SSHD config, is disable SSH agent, disallow agent forwarding. Other than that, I'm not aware of a fix. If you happen to do know one, please find me afterwards. I'll be more than happy to hear it. Yeah, that one was a bit anticlimactic. I'm sorry, guys. But this is kind of how it looks from like an attacker's point of view. Similar to Kerberos, SSH agents will store that socket file in temp by default. Because it's a socket file and not an actual file, you can't store it in the keyring. So when an SSH agent starts, it creates environment variable SSH auth sock. If your agent is not stored in temp, what you can do is a quick and dirty method is to pretty much strings all of the envron files for each process and just grep for that environment variable. And you will now have all of the SSH agents that are currently listening on that server. You can then kind of like run ls against those files to see who actually owns them, to figure out which user you need to start to impersonate to see if you can gain access to any other systems. How I typically do it is I create the environment variable before the SSH command, and then execute the SSH command in one line. You can create the variable yourself and then export it as your environment variable so that it will pick up on it by default for whatever other sessions you use. It's just a matter of preference at that point. How many people know what SSH multiplexing is? One, two, a couple, okay. Anybody know what SSH master mode is? It's the same thing, really. So SSH multiplexing is, I recently found out about this from a talk at DerbyCon as well, that you can use SSH multiplexing to bypass two-factor authentication codes. So the way the two-factor authentication PAM module works is when you create that SSH TCP connection, you're prompted for your code. That sounds about right. What master mode does is when you make that initial connection, it keeps that connection alive, regardless if your SSH session actually dies in the process. So while that initial TCP connection stays alive, you're able to then re-piggyback on that same session, on that same TCP connection with multiple sessions. And because the way the PAM module works, that initial, it only requires you to enter that two-factor auth code for that initial TCP connection. How this kind of looks is it would require somebody to modify either your Etsy SSH config or each user's SSH config that they're trying to target and enable master mode. So those three, the first block is what the attacker would use. The second block is what a defender can use. So the control master auto line will tell the SSH connection that try to establish a master mode connection whenever possible. The control path is where to store that socket by default. You can, as an attacker, you can tell it to store it anywhere that user would potentially have permissions. And you can possibly hide it so that they don't see it by default, unless some people alias ls to ls-a. And control persist is what tells the server how long to keep this connection alive for. So 0 tells it that I want to keep this connection alive for as long as you will let me. And what that allows is when, similarly to how you would use the SSH auth sock string, you can pass SSH, when you use SSH, you can pass the -s flag and point it to that file. And when you do that, SSH will renegotiate, check that that master mode connection is still viable and alive, and just piggyback on it. How you can disable it is you can set the max number of SSH, the max number of connections to 1. So what that pretty much tells it is for any master mode connection, only allow one session at a time. What this pretty much does is it disables SSH multiplexing. If you're worried about it affecting your environment, you didn't know what it was a while ago, so you probably don't need it. To kind of wrap things up, logging is important. Don't log to your own server, log to some central place that you can start to correlate things between Linux boxes. SE Linux and AppArmor are a pain to set up, but they're worth it. And you can tell people that I've actually implemented SE Linux properly. It took me 6 months, but I got it. I ran into somebody at DEF CON this year who went through that process. We were talking and he's like, yeah, I managed to get SE Linux working. I'm like, surprising. Like, how long did it take you? It's like a year and a half. Because they were running like JBoss, SQL, they were running a bunch of things. So it took him a while to get it. But getting an actual working SE Linux policy is quite nice. And then we now get into the same thing where you tell Windows people the same thing. Your admin account should be separate from the account you use day to day. I personally believe, oh right, there was no disclaimer. These are the views of myself. They do not represent my employer. For admin accounts, when you're actually separating them, make it a pain to use. If it's a pain to use, they're less likely to use it in their day-to-day tasks. If you set up that it requires two-factor authentication to get your ticket, to log in, to run sudo, they will probably never use it unless they have to. And they'll probably find a way to bypass it. Which, from my point of view, is also good. If they can find a way to bypass it, that means somebody else can, and probably already has. So that's a nice way for you to figure out how they've gone around it, and for you to hopefully patch it. That's about it. Does anybody have any questions? I would have had a demo, but as you can see, I started late. I was running around like a chicken without a head. If you want to see any demos, come find me somewhere else. I'll gladly spin up some VMs and show you kind of like the practicality of it. But yeah, any questions? Concerns? Heckling? No, it doesn't run on Arch Linux. It's not a real enterprise Linux distro. Anything else, Jeff? Yes. The concepts are the same. Thanks, Jeff. Anybody else have any questions? Jeff? Okay.
Yeah, just talking about if someone was looking for resources on hardening their Linux servers, what do you recommend?
So the question was, if you're looking for resources on hardening your Linux servers, what would you recommend? I would recommend starting with, yeah, like how you can do it too. Oh, if you're talking about guidelines, NIST and CIS have a couple of guidelines. They cover like most of the basics. They do also miss some things, but as a starting point, it's a good place to start. Anybody else? Is my torture over now? Thank you.